Train a language model with the usual reinforcement learning recipe, and it learns to write one good answer. But an agent does not answer once. Calls a search tool, reads the result, runs some code, corrects itself, and only then replies, sometimes across a dozen steps. Reward only that final answer, and the model has no idea which of those steps actually helped. ARPO, or Agentic Reinforced Policy Optimization, was built to close exactly that gap. Let us see how it credits the right steps inside a long tool using trajectory. First, let us pin down the gap that ARPO is built to close. Standard methods like GRPO and RLHF optimize a single response. The whole output is treated as one unit, and the reward lands on the final answer as a block. According to Turing Post, that works when the model replies in one shot, but it treats a multi-turn agent as a black box, so the useful intermediate tool calls and the wasteful ones get scored exactly the same. ARPO instead samples and optimizes at the agent step level, across the intermediate tool calls, observations, and decisions. The paper frames it plainly. The model learns which actions improve the whole multi-turn trajectory, not just whether the final answer was right. That shift lets reward flow to the specific steps that moved the agent forward, which is what long tool use genuinely needs. So how does ARPO turn a messy multi-step run into a clean training signal? Follow one trajectory through. Here the agent runs a full trajectory. It reads the task, calls a tool like web search or code execution, takes in the observation, reasons about it, and calls another tool, chaining steps until it produces an answer. Each of those tool calls and decisions becomes a point the algorithm can inspect, rather than one opaque block of text scored only at the very end. After each tool call, ARPO watches how uncertain the model becomes. The paper reports that token-level entropy tends to spike right after a fresh observation lands, because new information reshapes what the model might do next. Those high entropy moments mark the forks where the agent's path is genuinely undecided, and that is exactly where extra exploration pays off. Once a high uncertainty step is spotted, ARPO branches. Instead of committing to one continuation, it runs an adaptive rollout, sampling several alternative next steps from that same fork so the model can compare paths that diverge only where the decision was hard. That entropy-based branching, the paper argues, explores tool use far more efficiently than replaying whole trajectories from scratch. Finally, the algorithm attributes advantage across the trajectory. Rather than smearing one final reward over every token, it estimates how much each branch and each step contributed. So a genuinely helpful tool call gets credited and a wasteful one gets penalized. That per-step credit assignment is what teaches the agent reliable multi-turn behavior instead of lucky guesses. Strip ARPO back, and three ideas carry the whole method. This is the core move. Optimize at the agent step level, not over the whole response. By scoring intermediate tool calls, observations, and decisions, ARPO can assign credit to the exact actions that improve the trajectory, which is the thing single response reinforcement learning simply cannot see. Here, uncertainty drives exploration. ARPO uses the entropy spike after a tool call to decide where to branch, spending its sampling budget on the forks that are actually undecided rather than exploring blindly. That adaptive rollout, the paper argues, is what makes training long tool using agents practical. This matters because agents are where reinforcement learning is heading in 2026. Turing Post lists ARPO among the methods pushing reasoning and tool use forward, precisely because rewarding only final answers leaves multi-turn agents brittle. Better step-level credit is what turns a capable model into a dependable one. Alright, let us lock in what ARPO really is. ARPO, or Agentic Reinforced Policy Optimization, is a reinforcement learning algorithm built for multi-turn tool using LLM agents rather than single responses. Standard RL like gRPO rewards the final answer as one block, so ARPO instead optimizes at the agent step level across tool calls, observations, and decisions. Its signature trick is entropy-based adaptive rollout. Branch where the model is most uncertain after a tool call, then attribute reward across the whole trajectory. Remember that the payoff is credit assignment that actually reaches the right steps, which is what makes long tool use reliable. If watching how modern AI agents get trained is your kind of thing, come explore more with us over at standarity.com.